Oh my God. Okay, here's our first problem for the day. Give her a shot. You should work together, by the way. Remind each other how to set up force problems. I mean, what chapter are we practicing here? What have we been doing for the last month? What did I just ask you to lead up to this? Hint, 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 hint. What? Yeah, everything's done. Control H. Command H. Already correct answers? Oh my goddess. Yes, queen. Mackenzie, you do not need kinematics. Think about the chapter that we're on. Think about the skills we've been practicing. The equations I just hinted you should remember. Those are hints for how you should tackle this. Force! Do force! Do force! That's awesome. That's very appropriate. Oh my God, so many correct answers. I am very pleased. Keep them coming, baby. Okay, I'm gonna say one more minute. We've got a whole bunch of correctos. Okay, give me your best shot. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. All right, that's not too bad for a first time through. It's not enough. I want to go through this, go into this, because this is exactly the sort of thing I want you to be able to do. Remember, I'd like to do about a third conceptual, a third basic plug and chug, and a third problem solving on the tests. So this is like a third of the test is going to be things sort of like this. Not always friction. Friction isn't all of it, but still. Okay, so here's how to analyze this. Kinematics is last module, and you shouldn't forget it. Kinematics is good. Kinematics is great. But that's not what we're doing these past 3 weeks. We're talking about forces and dynamics. So let's think about the laws of forces that we've got. Well, as y'all just told me just a minute ago, kinetic friction is mu, coefficient of friction, times the normal force. So, well, let's see. If I know that the kinetic friction force is mu times, oh wait, what's the normal force? How can I find the normal force? Well, what do I know if I've got a truck driving on, I didn't tell you anything about an inclined ground. What do you know about the normal force? How hard must the road be supporting the truck? I think it should be supporting it as much as it weighs, right? So I would say the normal force had better darn well be equal to the weight force. The weight force is what formula? mg. All right. So there's the kinetic friction force. Any other things acting on the truck to slow it down? Any springs, any other horizontal, vertical surfaces exerting normal force, any ropes attached to this that I described? No, this is the only thing acting on the truck. Horizontally is the road, slowing it down with friction. So this is also, kinetic friction is the net force. Normal force is the net force. Normal force is the only force, therefore it's the net force. So the acceleration, finally, using Newton's second law, the only other equation that we've got, F over m is acceleration. Oh my sweet baby Newton, look, mass cancels, and I don't have to multiply by 10,000 at all. Gesundheit. Oh, 0.7 times 9.8, bang! Okay, now I will emphasize, by the way, that at the end of the day, if I'm talking about the vector, which direction is the friction accelerating this sucker? Negative direction. If you're moving in the positive direction, I'm going to say that the acceleration vector, negative 6.8. We're going to need that for the next part. And we've got a good third of the class plus getting this at this stage, which based on last week, I will take. Okay. Follow-up question. Test your remembering of, we're not going to go into a whole bunch of kinematics, but here's something that you really ought to remember here. Find the time it takes to come to rest. Google question F. I'm not going to go any deeper into this. Well, let's find the time. One of the core definitional equations in last chapter. Yes, correct. If you don't remember the equation, here, can you simply state the defining the definition? This is not using a complicated kinematic equation. It's using the core definition, the meaning of acceleration. If you know what acceleration means, that's all you need to plug in. Yeah, not the words, the equation. Do you know the defining equation for acceleration? What does that mean equationally? No, it's even better because a whole bunch of people skipped. We got more than half the class now getting this. I'll take it. And I'm gonna say that that's about time. Last chance for correct answers, though. One more for a correct answer, and then we got an even 50. 52 correct answers. I am the count. Okay, so here's how to solve for time in this equation. I write down the defining equation for acceleration. Acceleration is defined as the rate, that is to say the fraction, involving change in velocity over change in time. Okay, what is the change in velocity? If I start at 25 and I end at 0, final minus initial, over unknown that I want equals what? Equals acceleration is, we just solved up there, negative 6.8. Okay, so if I've got negative 25 over t equals negative 6.8, how can I get t alone? Normally I prefer coffee, but in this case we want t. I get t alone first, I get rid of the fraction, multiply both sides to get t, delta t out from downstairs, and then I divide both sides by what remains attached to him. .6 seconds. If you got 250 seconds, I encourage you to reflect on this. You're guessing an operation to solve the algebra. You have to write down the starting point and what you do in each step. As long as you might do a longer process than I just demonstrated, but as long as you do the same thing to both sides, you're guaranteed to get the right answer. So if your algebra is rusty as all get out, write down each darn step and don't skip steps. You've got to be able to do the same thing to each line. And yeah. Okay, good. Good. I'll take it. Let's do another problem. I'm going to skid to a stop. I'm going to run across the room and I'm going to skid to a stop, but I'm carrying a backpack. And I want you to consider the backpack as a separate object. Forget the backpack. It's cuter if I say I'm carrying Nalo on my shoulders. Okay, so Nalo is sitting on my shoulders and I run across the room and I skid to a stop or something. I want you to analyze this system, analyze this problem, and see, yeah, this is multiple bodies. I'll build it up for you. We'll build it up together. So here's the picture. Scenario 2. What am I going to give you? Here is me running. Let's just get as far as the acceleration. You've demonstrated that most of you remember something about acceleration. So there's Nayla sitting on my shoulders. I can't draw shoulders. Give me a break. I'll tell you that gosh darn it, the kinetic friction of the floor, let's say we're going into something slick, slippery just for fun. I don't know, 0.3. I think that's pretty slippery, actually. Coming to a rest on a buttered floor. I spilled some butter on the floor. My mass equals what? What am I, 60 kilos? Ish. His mass is, he's 25 kilos now. Soaking wet. Okay, so this, I strongly suspect we need to build up in pieces. I'm going to encourage you to analyze what forces act on me first. What forces act on me? And we're going to list the forces in triplet notation. Please alphabetize. Do you remember this? Triplet notation: kind, dealer, feeler. And alphabetize by the dealer because everything else has the same first letter. Yeah, right. So what are we? Step G. Let me see if you can. And by the way, I know this is awkward and tedious to put in. I'm sorry, but this is the only way I can check to see if you guys know what forces there are. I can't hand grade 75 diagrams. Identify the forces acting on me. Identify all forces on professor. Oh, yeah, we need to, this is P, professor or papa, perhaps. And this is Nalo N, and this is floor F, and guess what? There's a planet nearby. I'll let you decide which planet we're on. Identify all forces on professor P in triplet notation. Alphabetize by dealer. Alphabetize by dealer. Is this clear? Can you interpret this? Oh, I also need to tell you that he is not slipping off of me. Hint. He's not going anywhere. Let's say the static friction is 100. Not actually realistic, but I'm going to pick something to make sure he doesn't. Okay, people who are saying things, that's not what I'm asking for. I'm asking for forces. Okay, here's where y'all are breaking. Here's where we'll dig down. Hey, please check with your neighbor if you've got the alphabet in order, by the way. You are allowed to look up the ABCs if you need, because there are a whole number of people who are not actually alphabetizing here. Please, based on the second letter, the dealer, yeah? Check each other, because I want to hand grade this fast. Okay, I'm going to say time's up. And here's an example where we need to learn, where everyone is struggling, almost everyone, almost everyone. So let me encourage you, let's start. Let's start with NALO has fewer things interacting. So I'm going to step back and ask you to analyze not the forces acting on NALO, but the things interacting with NALO. Can you identify correctly what is touching or gravitating my sun? Put an H. Let me see that everybody can do this. Identify the objects acting on sun, on NALO. Not words, by the way. You don't need to type out words. Just type the letters. Give me a comma-separated list of letters. And check each other, please. Check each other, by the way. Oh, good. Mostly good. Please follow directions. I'm not asking for forces. I'm asking for objects. Objects, objects, objects. Single letters, please. Not triplets. Objects. Okay, I'm gonna call that time. The correct answer is there is a planet nearby, Earth, and there is a professor in contact with NALO. So the correct answer is EP. A lot of people got that right. Many people got that right. Okay, now let's identify the nature of these forces, the nature of the forces acting that are causing each of these. So you should have written objects acting on NALO. He is a person, capital letter, are Earth and professor. That is not a proper noun. What kind of force or forces does each object exert? When I'm asking for kind, I'm not asking for a triplet. You could just write the kinds of forces, the single letter that you would use. F for FK for F for friction, N for normal, W for weight, FE for elastic, which we haven't talked about yet, so don't. What's the last one? What's the last one that we haven't? T for tension, whatever applies here. Arizona's too conservative for me to teach you about drag. Hey. Oh, it doesn't matter. Oh, I wish people could follow directions, though. I'm not asking for triplets. I'm not asking for words. I'm asking for kinds, just letters. Just single letters indicating the kind. Okay, time's up. There are three kinds of forces that are acting on Nalo. There is a normal force that I support him, otherwise he'd fall. There's a weight force, duh. By the way, what letter do we use for weight? Is it G? Don't call it gravity. Call it weight, please. Let's use consistent notation. And the third thing is, if there's no horizontal force on him, is he going to move with me? If I am skidding to a stop on this, maybe it's a rug. Let's say it's a rug. That would be a reasonable coefficient of friction for a rug on a smooth floor. If I'm skidding to a stop on this rug, then if he has no horizontal force on him, he's going to go flying off. Also, I drew a big hint on the diagram when I said that there is a mu pointing to the interface between us. Yeah, if I'm telling you the coefficient of friction between, I guess, my head and his feet, that's a big hint that that's an important force. So there are three forces on him. Correct answer is friction, normal, and weight. Okay, now this is a big surprise for lots of people who didn't recognize that I also exert a friction force on him. Question? Sure, FS works. I'd give credit for that. Here, F in parentheses S, sure. Now, this is a big surprise. Very few people indicated that there's a static friction force on him. Let me encourage you to reflect on this again. If he's slowing down, if he's staying on my shoulders, if he's sticking on me, staying with me, if he is to slow down with me, there has to be a force slowing him down. He will not change his motion. He will stay moving in a straight line at constant speed if all that's acting on him is normal in weight. So far, so good. Let's check to see if you guys, if everyone, how many of you, can do the triplets for these forces. I've identified things that exert forces. I've identified kinds of forces. Question J. Question J. List the three force triplets again. The three forces acting on him. Triplet notation. So we identified the kinds. In I, previously in H, we identified objects acting on him. Can you put these together? Yeah, question. Yes, please. Alphabetized by object, by dealer in general. Yes, yes, yes. Please turn to your neighbor. I've got a whole bunch of correct answers. I do have some answers that are simply not following the format, not following the instructions that I've given. Please help each other out. Show each other the way. Do you know the way? You guys don't know that meme either. That's fine. It was a stupid meme. One minute, please help each other. I do want to emphasize here, I had a fair number of people add more forces. We identified there are only two things capable of acting on Nalo. And one of those two things, me, can act on him with more than one kind. But I did have a fair number of people tell me that the correct on the first two and then tell me that the floor starts acting on him suddenly. Floor does not interact on him. You told me the floor doesn't act on him. I told you the floor doesn't act on him. Don't introduce new forces when they don't apply here. Okay, but there we go. That's the list of the forces acting on. Now, the last big step here to help you that I see people missing left, right, and center when I was asking before is which of these forces have a third law pair that acts on me? Which of these forces has a reaction on me? Which force or forces in this list also push on me? I guess a simple way to say this. List the forces that Nalo exerts on Professor. Look at the previous answer, by the way. I'm building you up to this. Question J tells you question K. If you understand, if you know what the third law says, this is I'm showing you how to reason through this instead of just telling you things. Now, also relates to the if they're just like it only has one leg. What's your email again? YCO, what? YCO? Okay. Yeah, I gotcha. Okay, so the big trick that I taught you, or tried anyway, the big trick that I discussed when we were talking about Newton's third law is if a dealer acts on a feeler, then that feeler acts back on the dealer. So if you just look at the subscripts and flip them, then that's a third law reaction. The normal force of professor on NALO also means that NALO exerts a normal on professor. NPN, NNP. Oh my God, that's a force that N exerts on P. NNP. Likewise, the friction force, static friction if you wish, of P on N, if I static friction him, then he static frictions me, Fs if you like, NP. Weight force of Earth on NALO, the third law pair of that is NALO on what? On Earth, not on me. Earth is not acting on, or he is acting on the Earth, but that's not what I asked about. I asked for forces that he exerted on me. So the correct answer here is the I would say static if you wish, normal NALO on professor, and normal force of NALO on professor. Don't forget the third law just because we've been doing a bunch of other stuff. You need this. I will test on this. This is big. This is a substantial fraction of the test of physics. Okay, so knowing this, I'm going to move you forward just a smidge so that we don't spend the entire darn class on a single problem. Move you forward just a smidge. The total list of forces acting on me, I should say P, those are the vertical forces. NALO sits on my shoulders or stands on my head in the diagram, I guess. He pushes me down. Third law, if I support him upward, if I push him upward, he pushes me down. And the weight force of Earth on professor, duh, right? Furthermore, I know equations here. If he weighs, what did I say? If he masses 25 kilos, what's his weight force? 250-ish, right? 250 newtons. So what normal force is he going to push down on my head with? 250, right? If he weighs 250, there's nothing else acting on him. He must be supported by 250 newtons. So I could say the normal force of NALO on professor is 250 newtons downward. What's the weight force of Earth on professor? I mass 60 kilos. Google form L. What is NFP? I am hoping this is an easy one. I'm asking you for a number, by the way, not a verbal description. Hmm. 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 I'm glad I checked. Okay, no, this is not okay. This is not okay here. We need to fix this. You need to know how to find this here. I have half the class telling me that the normal force of the Earth on me is only 600 newtons. Another half the class telling me that it's 250 newtons. And the third half of the class is telling me that they're 850 newtons. Wait, does that add up? Does that add up to one whole unit of class? No. And likewise, a large number of people are not telling me things that add up. Am I accelerating vertically? No. What's the total force on me? Google form, question M. What's the total force acting in the vertical direction on the professor? You know that I am not accelerating up and down. What must the total force be? Google M. This is M. Okay. Newton's second law says that my acceleration is my total force divided by mass. We just said that the acceleration is 0. If acceleration is 0, what divided by 60 is 0? It's not 850. The correct answer is net force must be 0. There can't be an unbalanced force acting on me and have me not accelerate vertically. So the total force on me has to balance to 0, okay? Now, there are two forces acting downward. My weight is 600 newtons. Nalo is pushing down on me with 250 newtons. The net force on me has to balance to 0 newtons. I ask again, Google question N. Tell me what is the normal force that the floor is supporting me with. Please put together the puzzle pieces. I just gave you all the things you need to know. Now drink from the lake I led you to. Find NFP again. That's more like it. Mostly. Okay, I've got 60% of you with me. The correct answer is 850 newtons. If I am pushed down with 600 and 250, I need to be supported with 850. Remember what net means. I add together the forces. I add together the forces. Net means total. Ups are positive, downs are negative, as usual. So I have my unknown plus negative 600 plus negative 250. And what does that net equal to? It must be equal to 0. The correct answer is normal force is 800. Normal force of floor on professor must be 850 newtons. Okay. That's most people, but it's not all. Please, 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 please turn to your neighbor and discuss. I'm leading you in a step-by-step process for how to deduce stuff, but you need to be able to do this much. Okay, so turn to each other and discuss what the hell is going on. Why are the answers here 850 newtons, and make sure you can get to 850 newtons for this. Last. There's force. Weight force would be just pressure, weight, so you multiply the that. So there's a 5.8. And then in the normal force, floor of the pressure, you gotta add up all the forces of whatever is on top of the lower section. Or whatever is touching the professor and like as the professor is touching the floor. So in this area, and those got at well their doing it up or their weight. Yeah, which is not the amount of weight that pushing down on the floor while also the floor is pushing up. Okay, I want to emphasize just a couple of points, a couple of maybe nitpicks here that are important. I'm not just being nitpicky for the sake of being anal. NALO does not push down on me with a weight force. I want to emphasize this. Weight forces are long-range gravity forces that only you exchange with the Earth. Or maybe your mama. Right? So normal force is how two solids push on each other. Weight force is how gravity works. Weight force is long-range gravitational. NALO can't gravitate me. He's tiny. I'm macroscopic. There's no gravitational force between us. He doesn't weight force me. Now, the normal force is equal to his weight, right? But that's not always going to be the case. If we're in an elevator, it's not. If there's something sitting on his shoulders, it's not. For instance, as we deduced here, I weigh 600 newtons, and the normal force of the floor on me is not equal to my weight force. If there were only 600 newtons up and 600 plus 250 newtons down, I would have to fall through the floor. So that's point 2, by the way. Normal force on you is not always equal to weight force on you. I have a fair number of people who get so used to normal being the thing that is up and weight being the thing that is down, get so used to that that they say normal is always equal to mg. There is no equation for normal. Normal force is whatever it needs to be for the surfaces not to phase through each other, for there to be the acceleration to be equal or 0. Reflect on this, my grasshoppers, and achieve physics enlightenment. Okay, now we're going to move on. We're going to find how NALO acts on me. NALO acts on me. There are 2 things acting on me. No, I should finish this first part. Okay, you know the normal force of the floor on the professor. Can you use this to find the friction force of the floor on the professor? Yes, you can. Now do it. Kinetic friction of floor on professor. Do you guys know the problem? Find floor's kinetic friction. Here's the original problem statement, by the way. Gesundheit. Good, 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 good. Good, good, bad. Good, good, bad, good. I'm going to encourage you to look at the formula that we started the class with. All you got to do is plug in. I will again hint that you have the equation right at the top of your page, or darn well should. All you got to do is plug in. Okay, time's up. The equation for friction is, kinetic friction is mu times normal. What's mu? What did we just discover the normal force the four exerts? 850. 0.3 times 850 is 255. So if you simply plug in, the formula tells you $255 newtons. Now, the last question here, the last tricksy question, the last challenge question is, how can I guide you to this? Because this is so many people make this mistake last year. How can I hint this appropriately to get you there? How can I give you this hint? In words, I can't think of a way to give you this in symbols or letters, so I'm gonna have to read in words. Oh, mu s times Nalo's normal. Does that equal Nalo's friction? Mu s times Nalo's normal force. I gave you his static coefficient friction, and his normal is equal to his weight in this case. Does that tell you his friction force? Yes or no? Y or N? This is Google question P. Do you remember static frictions? And I'm going to call times up. And you did way better than at least what my memory says is last year's result. I didn't guide it in exactly the same way. Maybe I'm putting my finger on the scale here, but still, I'm pleased. Got a fair number of people who remember. No, mu(Sn) does not tell you the value of static friction. Mu(Sn) tells you the max friction that static can provide before slippage occurs. Mu(Sn) tells you the maximum value that you can have, not necessarily, unless you know you're just about to slip off my shoulders, not necessarily what is happening. Okay. So what you can conclude is that he does stay on my shoulders. So whatever the acceleration is in the system, whatever the acceleration is going on, you could use F equals ma to find the horizontal force, which is his friction force, as we discussed earlier. So apply F equals ma and write down an equation for me. You don't have A yet. Write down an equation that you could use if you did have A to find his friction force. You can't just use mu(n). So give me an equation that would give Fs. I just told you, by the way, I just told you exactly what to do. Now, can you spit it back to me? Google question Q, what did I just say that we would do to find his static friction force? Give me an equation. Something equals, Fs equals blah, blah. And we just said that you can't use mu(Sn), so don't tell me mu(Sn). Okay, let me repeat myself again. This is an are you listening question. Please listen. With static friction, unless I specifically tell you you're at the absolute limit, unless I tell you you are just about to be breaking free, you can't use mu(Sn). You have to use other information about the problem. For instance, if you know that he's sticking on my shoulders, if you know that he's staying with me, which he is, huge static friction coefficient, you would apply the idea if he's accelerating at my rate and you know his mass and you know that the only force horizontally acting on him is the static friction, apply Newton's second law. Newton's second law tells you how much friction force must act on him in order to accelerate him up at the same acceleration. You don't know acceleration yet, that's our goal here that we're finding here, but you can write down an algebraic expression, Newton's second law, involving the variables and constants given. Tell me an algebraic expression for how you could connect the puzzle pieces to get Fs. This is, go ahead and edit question Q. Give me an equation, not words. And by the way, this is how you'll just about always find static frictions. You will apply Newton's second law, which, as I just said, the only force acting on him is the static friction force. Newton's second law, F equals ma. So all you got to do is write down that the static friction force is ma. The correct answer is Fs equals 25a. Write this down. Take a note. Reflect on this for a second. To find static friction, unless I specifically tell you you're at the limit, don't use mu Sn. There is no equation for static friction. It's whatever it needs to be to keep things moving or not moving, to keep things stuck together. So if you know that something is accelerating, or if you're going to plug in to find that something is accelerating with acceleration A, you know the mass of that object, then you've got an equation. F equals ma. The only force acting horizontally is static friction. That had better darn well equal ma. So the correct answer for Q, again, is Fs equals ma. Great. Now, we've got all of the puzzle pieces we need. Here's the horizontal force acting on me. Take you to the final step, just in time. He acts, which direction did I say we're going? I didn't say which direction we were going. Whatever. He acts backwards on me. If I am moving to the right and slowing down, he acts forwards on me. Friction static of Nalo on professor. The kinetic friction of floor on professor. How you reason about this is if I am slowing him down, I am exerting a backwards force on him. He is pushing me forward, Newton's third law. That force acts in the opposite direction. Now, I think the kinetic friction force is going to be bigger if it's slowing me down. I could write an equation then. My acceleration times my mass, what is that? What is 60 times A, had better darn well equal the, let's say, I would actually want to say that that is in the negative direction, right? Right? I am backwards acceleration. I'm going to let A be the magnitude of the acceleration there. Negative 60A is the net force acting on me. Equals, what did I find the kinetic friction is? 255? Wait, am I plugging this in backwards? Am I plugging this in backwards? I am. And I know the equation for his 25A is what we just deduced. There we go. Whew, took me a second. So this is ma for me, and this is net force for me. Now, I challenge you, here's the final step. Please algebra carefully. Can you find acceleration? Google form R. I've given you a one variable equation, find A. And the magnitude of the acceleration. Start in R. R. Incidentally, this is how this problem-solving process that I've walked you through is how you would solve any of these problems. We're analyzing the forces acting on these objects. Identifying that Newton's third law says that the forces on both objects forces acting on interacting objects act on each. Apply Newton's third law to interactions between the two objects and write down an equation, F equals ma, for each object. Okay, and here's how to solve algebra. If I have a's on both sides of the equation, I want to get the a's together so they can make lots of a babies. If I've got negative 60a and 25a on the other side, I would add 60a to both sides. 60a plus 25a is 80. Whoopsie, where'd that plus sign come from? 85a minus 255. I don't want the 255. I don't want the 85. I'm going to add to both sides to get 255 equals 85a Then if I want to get rid of the 85, I divide both sides. 3 meters per second squared. Take a look at the individual steps. And on Wednesday, we're going to do one final equation, spring equation, just one. Then we're out of here. Then it's finals time. Finals, midterm time. Adios, everyone.